Okay, thanks, Jack. The author of this paper was Hamid Golizadeh, who is supposed to be here, but due to visa issues wasn't able to make it. That's his photo up there. And Carol Hon is his principal supervisor. She's the expert in safety, and I'm providing the BIM input to the research. So since I didn't prepare the presentation, I hope you will forgive any minor slips of memory. Okay, so normal structure, look at the background, what we're trying to achieve, then where we currently are, and hopefully some time for questions. Anyway, our industry, the construction industry, is poorly perceived in the health and safety area. 60,000 workers around the world being killed every year is not the sort of KPI we want. If we look at the fatalities in the US and Europe, around the fatality rate for the construction industry is about 20% of all work-related deaths. Within Australia, we have about 50 deaths a year in a population of around 25 million, with about 1 million of those working in the industry. 50 people a year out of 1 million people doesn't seem like many unless it happens to be you, and then it becomes a bit more important. But one death a week is still too much. Some changes in Australia that are impacting like that is that now the employers, the managers of companies actually can face a charge of corporate homicide, which tends to motivate them to pay a bit more attention. Okay, so when we are looking at safety and so on in BIM, work health and safety actually suffers from many of the problems that BIM has, where they've been doing stuff in 2D. The person who knew most about safety was the Occupational Health and Safety Officer, and they'd normally run around site picking up on issues that people would then ignore. And then lots of issues about training and so on. So from the health and safety perspective, we should all be familiar with that sort of thing. And when we try to move to virtual environments and using 3D models, many companies are now actually using BIM to do their what we call the SWIMs, their safe working method statements and so on, and even doing on 3D or 4D models in order to train people up in difficult operations. So BIM is having an impact on safety. And then the 4D is actually a really good way for even inexperienced construction planners to recognise potential safety issues. So where we started with this, there is a lack of research on how BIM is going to impact on OH&S in Australia. And we're actually turned this around a little bit. We're taking a problem-driven approach. We're actually looking at what are the causes of accidents and which are the major ones, and actually trying to analyse reliable data. Interesting number, I was reading an article in the New York Times. They said that in the US, something like 1/3 of the causes of deaths are actually incorrect. And if you actually look at OH&S data, many of the causes of accidents on site that are non-fatal tend to make sure that none of the people who write the report are to blame. So we took a much more, reliable approach, which I'll explain in a minute. Okay, so Hamid's also been looking at innovation theory and how innovation spreads through industry, and looking at the issues around identification of the problem, evaluation, commitment, preparation and implementation. And he's been using a causation model that was developed at Loughborough University with lots of surveys and interviews with and focus groups with victims, witnesses and so on, so it's apparently a fairly reliable model. And they've built this around systematic interaction of the factors, and it has been used and validated by other groups. So this is a diagram of the model. So it's got 3 major components. The first bit is the circumstances around the actual accident. So this is the immediate accident circumstances. The arrows all over this laser pointer work there. The arrows here are causal factors in this. So it's a 3-tier. We start off with what happens around the accident itself, And then the shaping factors, the things in the environment or the project which directly impact on that. And then the originating influences are say, the culture of the organisation or the organisations and how the team is structured. Hamed analysed 109 fatal accidents in Australia. This is reliable data because fatal accidents are examined by a coroner who has no vested interest and actually digs very deeply into what caused the accident. From those 109 cases, he managed to pull out 487 causes, and the most impactful ones are the ones that he's highlighted there in yellow. Then he's gone through a series of interviews with industry experts in BIM. So he's gone through and identified the causal factors for the deaths, and then he's gone and spoken to people who have significant experience in BIM and asked them to identify what aspects of BIM could then be used to mitigate the causes of these accidents. So it's a little bit different to the approach that many people who have a much more of a BIM focus say, oh, I've got BIM and okay, this can help in this sort of accident. So we're approaching this from a different direction. So as you can see from the table there, there's a fair amount of experience there, and he did very detailed interviews with these people to try and maximise the outcomes of the research. Under evaluation, he's looked at issues around training. So how do we train the industry? How we can actually look at design for safety using the 4D modelling, which is related to that. Then how do we actually monitor on-site processes, and also the opportunity of using, well, he's used BIM as a digital library here, but how can we actually use BIM in order to share experience across the industry and change culture? And then issues around how we can use BIM to pick up issues around particular pieces of equipment and also material supplies. And if you think of the Grenfell Tower disaster, where there was a totally inappropriate use of materials, which could have been picked up if anyone had bothered to read the manufacturer's literature properly, we can understand how important that can be. And then there's lots of discussion in Australia, at least, about now that the external cladding issues come up, how you could actually go back and find out which buildings have materials in them that are now recognised as being unsafe rather than at the time they were installed, and asbestos is an obvious example of where that sort of thing could help as well. So the issues around commitment, obviously goals are important. If you don't set some goals and you don't know what you're going to achieve, issues around trust, and then commitment by contractors and designers to really look at these issues to maximise safety. Issues around the large companies acting as industry leaders and driving change, and because of the nature of our projects and the way people move between them, if the big players start introducing initiatives, then they'll slowly infiltrate through the rest of the industry. Issues around the cost of technology for smaller firms, and there's the hope that vendors will start adapting their software to support these sort of issues. And then all sorts of issues around identifying the scope of safety management within projects. Okay. In preparation for this, you basically have to have the appropriate technical hardware and software in the companies. The issues around the time and budget, potentially using automation in the software tools to smooth things, make the uptake more efficient, creating new roles and responsibilities. On we have the BIM managers in projects now. We have explicit OH&S people. There may be another role that emerges out of that. Government mandating BIM will also help uptake into safety management, and the issues of industrial manslaughter, once again, are helping there. In our projects where we have lots of subbies, how to actually disseminate this information into subcontractors, and given the way our projects are put together with virtual organisations, or there would be all sorts of issues around interoperability and information exchange if we're going to have consistent systems across the entire team working on projects. Then issues around the compatibility is the same sort of thing. The use of industry associations to drive this. Universities also have a significant role here in just training people. I don't know about in New Zealand and other countries, but in Australia we don't even have enough capability within universities to train people for BIM, let alone specialised aspects of BIM. Which leads to the other one about availability of safety managers who know anything about BIM. And the old chestnut about conflict in intellectual property. And then what are the financial incentives to actually encourage industry change? I keep pressing the wrong button. Then with implementation, you've got the issues around continuous monitoring. If we actually start having processes about using BIM for continuous monitoring of progress on projects feeding into cash flow, for example, then there's opportunities to leverage that into the recognition of OH&S issues. How do we get the information about this to subbies? The issues around liability of data. Oh, you didn't tell me this was happening, so it's your fault that the accident occurred. And then how do we actually build BIM models to incorporate the safety information? How often do we update this? And then how do we provide this information through to asset management, facility management later on, where people have to come in and maintain things? I think Robert had some nice pictures of pumps down in the basement of your building. So how do we maintain that? And then the issues around continuous collaboration between designers and contractors during the project to keep the models up to date. And then the overarching thing about just supporting effective communication, which is supposedly one of our excuses for doing BIM to start with. So these are the references that Hamid used to put all of this together. And I'll answer any questions that you have or attempt to answer them, and if I can't answer them, you can email Hamid.